Imagine a time when there was nothing, no stars, no planets, no molecules, not even time. Then what happened suddenly? Let's watch the video till the end. Welcome to my channel, The Ever Evolving Scholar. Before we dive deep into the topic, I will request you to like, subscribe and share. Big Bang. About 13.8 billion years ago, the universe expanded from an unimaginably hot and dense point. In the first few moments, it was pure energy, too chaotic for atoms or molecules to exist. But as it expanded and cooled, things started to change. The first moments of the universe. The universe was so hot and dense that even the fundamental forces of nature, gravity and electromagnetism, and nuclear forces, were unified. This era is known as Planck era, which is about 0 to 10 to the power minus 43 seconds. Physics, as we know, breaks down in this era, as quantum mechanics and gravity doesn't work. We don't know much about this time. Then, the universe expanded and cooled slightly, causing gravity to separate from other forces. The remaining forces like strong nuclear force, weak nuclear force, and electromagnetism were still unified. This era is known as Grand Unification era, which is 10 to the power minus 43 to 10 to the power minus 36 seconds. The next is Inflation era, 10 to the power minus 36 to 10 to the power minus 32 seconds. The universe expanded faster than the speed of light for a fraction of a second. Tiny fluctuations in energy distributions were stretched out, forming the seeds of future galaxies. Electroweak era. The strong nuclear force separated from the weak nuclear force and electromagnetic force. This allowed the universe to stabilize slightly, but it was still too hot for the particles to exist normally. The formation of matter. The universe was cooled enough for quarks and gluons to form. These are two fundamental building blocks of matter. This era is known as quark era. As the universe expanded further, the quarks finally combined to form protons and neutrons, the core particle of atoms. This era is known as Hadron era. Electrons, neutrinos, and other light particles like leptons started interacting with protons and neutrons. This era is known as Lepton era. The universe was now filled with dense soup of protons, neutrons, electrons, and photons. The first atom, the birth of hydrogen and helium, 3 to 20 minutes after Big Bang. Around 3 minutes after Big Bang, the universe was cooled enough for protons and neutrons to fuse, forming the atomic nuclei. This process, called the Big Bang's nucleosynthesis, created mostly hydrogen and helium with tiny amounts of lithium. However, the universe was still too hot for atoms to hold on to their electrons, so everything was in the form of ionized plasma. The first light, the cosmic microwave background. As the universe continued to cool at about 3 lakh years, Atoms were finally able to capture the electrons and form neutral hydrogen and helium atoms. This marked the end of hot plasma era, allowing the light to freely travel for the first time, creating the cosmic microwave background, the oldest light in the universe, which we can still detect today. Now, we are at the end of the video. Let me know in the comments how much you liked the Big Bang. So many things happened later after Big Bang. The atoms are formed, the life has been generated, and so many things. We will discuss it in the next video. Stay tuned. Till then, like, subscribe and share. Thank you.